Assalamualaikum and hi, we are from Group 2 ECV 3213 Structural Analysis 2. My name is Nabil Iman bin Muzaffar, my matrix number is 204 and here are my group members. So today we are going to present about our group project. In this project, the local authority requires a new building to serve as a library. For this 3-story library, the client proposed a reinforced concrete building with lightweight glass curtain walling fixed to floors and columns. So in any construction project, it is very important to carry out structural analysis to evaluate the design and its ability to withstand forces exerted and its moment. So this pre-construction analysis is done by manual calculations followed by software computations, which is SAP 2000 version 20. So this structure is built under Eurocode's provision. And the standardization are as follows: Eurocode 1 actions on structures, Eurocode 2 design of concrete structures, and Eurocode 3 design of steel structures which are used on the trusses. And here is the client's proposal plan. The frame area, which are 30 times 22.5 meters squared, the frame height is 11 meters, and the truss height is 6 meters. So as engineers, it is our job to prepare structural analysis report of the full building in 2D and 3D, both manual and software analysis.
My name is Wano Husnina Meti Muhammad Nizar. My metric number is 202450. So now I'll be proceeding with the problem statement of our project. The first point is what is the suitable method to be used to analyze the 3-story building under Eurocode's provision of subframes analysis. The second point is what are the consequences of the modeling approach or assumptions. And the third one is what are the difference value obtained through 2D, 3D and manual analysis based on the result obtained. So this is the assumptions of our project. For our truss, we decided to use material steel with a density of 78.5 kilonewton per meter cube. And for the height of the roof truss is considered to be 6 meter. And for the type of steel is we decided to choose lightweight truss that has an area of 268.56 millimeter square. And for the column size is 300 millimeter width times 400 millimeter of height. And for our beam size is 250 millimeter width times 600 millimeter of height. And for the slab, it has the thickness of 300 millimeter. And lastly, for our load, the live loads are not considered in our project.
Okay, now we go to the frame methodology. As you can see, we need to first determine the type of our slab, either 1-way or 2-way, and then we calculate the UDL of our structure. And in our case, we have determined it as 2-way slab using the formula stated, and then calculate the N equal to 1.35 GK plus 1.5 TK, and GK will also included with the slab self-weight. After that, calculate the UDL, which is also included and added with the beam self-weight. After that, the last step is to calculate the K, DF, and FEM using the formula that we have been used before in the class.
Assalamualaikum. My name is Farah Adila binti Ahmad Marzuki. My matric number is 203699. Now I will proceed with the results for manual calculation of roof truss. First, the dimension and the properties of the truss are assumed such that the cross-sectional area of truss is 2.6856 times 10 to the power of -4 meters squared, and the density of truss is 78.5 kilonewton per meter squared. Next, the permanent load GK, which is the roof sheeting and insulation, is calculated. So 1.2 kilonewton per meter squared is the load for the roof truss. The self-weight of truss is also calculated using formula area times density times length. Then the point load at each joint on truss is calculated. The both end of the truss receive 11.04 kilonewton, the other two receive 18.4 kilonewton, and at the top receive 14.72 kilonewton. Moving on, the forces in the primary structure are calculated. There are 4 primary structures drawn, 1 due to the actual load and then the other 3 due to redundance. The primary structures are analyzed using Excel computation. This can be done by producing a table for the truss member internal force. Afterwards, the compatibility equations are produced and the redundant values are determined. Lastly, the support reaction and the internal force of the real truss are calculated. So this slide shows the final result of the manual calculation. Thank you.
Alright, so here is the result for software analysis of truss. So there are two analyses that have been done, which are the values of support at joints and internal forces at members. So to do this in SAP, we need to define the materials, the structural members, and apply GK load of roof sheeting and insulation with value of 1.2 kN per meter squared. So first, we look at the joints. The supports at point A, B, D, and E are pin, fix, pin respectively. So the pin support have both X and Y directions, while fix have only Y directions. So the value are as follows. So as we can see here, the percentage difference are very small, ranging from 0.149 to 1.364. So this shows that the results from manual and software are almost the same. Then we look at the internal forces of the trusses. So we have 13 members altogether. The calculations between manual and software are compared. So the negative values are referring to compression members and the positive are tension. The percentage errors are ranging from 0.054 to 4.152. So which is still considered very low. So this proves that there's no significant difference between manual and software calculations, and our manual calculations are proven to be true. Lastly, here are the 3D trusses that are built by using SAP 2000 version 20. So the values are the same as in 2D, but in 3D there are additional members such as purlins and bracings that are added to the truss.
The free analysis, as you can see, the joint at J is summation 0.068. We can't get a 0.0 because there are some, because due to the significant figures that have been taken, that we used in the calculation. And if you can see, this is the first floor max because we have split into two, the first floor and second floor. As well as the max here, max is indicate that as you can see, it is a plan at library floor level. The max is the green one, which is the two UDL acted on the same beam, which is and then the minimum moment is the one that the blue one, which is it have only one UDL acted on that beam. So that's why there are two cases, the maximum and minimum one. So that's all. Thank you.
Hello, doctor. My name is Song Jincheng. My metro number is 20067. Today I will talk about the SAP 2000 result for 2D and 3D frame, and then I will compare the percentage error with the manual calculation. So firstly, this is the front view first floor maximum moment. This is the minimum moment. This is the front view second floor maximum moment. This is the minimum moment. So we go to the front view top moment. Then we go to the side top moment. Then we go to the second view first floor maximum moment. We go to the minimum moment. Then we go to the side view second floor maximum moment. Then we go to the minimum moment. Then we go to the sandy modeling. the 3D modeling front view moment, and the side view moment. Then we go to the error percentage for the front maximum moment. So we go to the minimum moment. Then we go to the side view maximum moment.
Hi, Assalamualaikum. My name is Nur Aniza binti Amran. My metric number is 196036. So for the conclusion, throughout this project, manual calculation consumes more time and there might be error, especially when massive amounts of data are involved. Hence, software is always opted for a quick and more accurate analysis performance. So by using SAP 2000 software, we produce two-dimensional and three-dimensional roof trusses, beam and columns for the building. And the percentage error in this project between the manual calculations and analysis from software for frames that do not include the beam below on the truss is a small error that does not exceed 0.5%, while the percentage error for the beam below the truss that is attached to the column has the large percentage errors. Then we recommend that we should try the different types of software such as Lean Pro structural analysis to analyze the building structure. With that, they can different analyze and compare which software provides better outcomes. And we also need to consider other factors that contribute towards the structure and client's need. Other factors include environmental, social, and its topography area. We also need to consider about the cost of the whole project for the building. That's all from our group. Thank you.